I really picture Africa as desert and animals and dried up water holes and the natives.
I always pictured Africa to be more just dirt roads.
Nobody thought that Africans could be scientists. I think we've achieved it.
I think of these black children, maybe starving.
Basically starving. That's about it.
It's just a land in disaster right now.
We have got to align science with the development of our countries, and I think we are really the first generation of scientists that are doing that.
Africa by itself has to now invent its own solutions.
After 25 years, Thomas Odhiambo is leaving. On this rainy night in Nairobi, he's writing one of the last speeches that he will make as director of the laboratory he built from nothing into one of the world's leading centers for the study of tropical insects. It's the first of its kind in the tropics. 2,000 miles to the south, the rain also falls in the tiny kingdom of Swaziland. Chemist Lydia Makubu is late for her plane. She's taking yet another trip to the rich world to promote science and education in her world. This is their story, a story of struggle for recognition and achievement in a world that only seems to see Africa in terms of its problems and failures.
I've always wondered why Africa was not in the forefront of science, ever since I was in school. I could not see and I could not believe that people had been given talents in Africa which are different from talents elsewhere in the world. And part of my purpose was to convince myself that it can really be done. To prove the point that you can do excellent science on major problems of importance to Africa within Africa.
I have to add some water.
So most of the Malamoeba will be found in
Malpighian tubules, yeah. So,
although they are transvarially
yeah,
transmitted,
yeah,
but they actually, the site
is the
of pathogenicity is Malpighian tubules.
Yeah.
Thomas Odhiambo has devoted his career to advancing the study of tropical insects. Insects dominate life in Africa in ways few people in developed countries can comprehend. They destroy up to 1/3 of the continent's food potential. They carry devastating parasitic diseases like sleeping sickness and malaria, diseases that have killed millions. Yet Tom Odhiambo merely calls them pests.
The damage by insects, both in the field as well as in storage, are extremely high, really very, very high indeed. For good reasons, good climate, high temperatures. You couldn't have it better if you're an insect. And so it's a real question of managing the insect population. By understanding their biology thoroughly, understanding the relationship with their host, whether plants or animals or humans. And because environment has always been important to us, sustainability has always been at the core of our work. Our concentration is certainly, let's manage the insect populations. Manage in such a way that we do not harm the environment. We do not harm the non-target organisms that are in the same environment, but that we take out the negative aspects of insects. Our philosophy over the period of time of 20, 25 years has homed specifically on non-polluting systems of pest management.
This is Tom Odhiambo's pride and joy, ISIPE, or the International Center of Insect Physiology and Ecology. On the outskirts of Nairobi, Kenya, it was built on Odhiambo's belief that to solve scientific problems relevant to Africa, you had to have a research center in Africa.
You cannot see the exotoxin. You have to buy us.
And you had to have African scientists who understood the problems doing the work.
When I first met Tom Odiambo in Isipe, and I said to myself, what a tremendous man, because Tom has 1,000 ideas of how to advance science in Africa. And all of those ideas are very sound.
Lydia Makubu has a lot of ideas of her own. She trained in Canada as a biochemist, becoming the first person from Swaziland ever to earn a PhD. She spent her scientific career there studying the potent chemicals found in African plants.
No, I don't think so. I think I want to keep her out of the limelight until she's finished school.
Today, in addition to being a mother, a leading scientist, she's also vice chancellor of the fledgling University of Swaziland.
I think it needs to be filed carefully as a notice, but I have a letter here. The university has been growing steadily. This year, for the first time, we have gone beyond 2,000 students, which may not be very much when you compare that with the enrollment in bigger universities, but this is a small country, and 2,000 students in a population of less than 1 million inhabitants is fairly heavy. Science that is going to advance Africa is the kind of science that is going to be sensitive to the needs of Africa. And the needs of Africa must be interpreted by those who are on the ground, who understand the social circumstances, who understand the cultural sensitivities and the politics of Africa. So it is extremely important for educational institutions in Africa to really get up and produce the kind of people that are going to be able to generate new knowledge in Africa.
Lydia Makubu's roots are in the highlands of Swaziland. When she was a girl, schools were few and offered little. Makubu's primary school has grown since she was in grade 6.
I come from a mission school. I went through mission schools, and most of the schools in the early days were missionary schools. And the people that went through missionary schools have done well.
What happens to the air which was inside the scalp? First night, it came out, right?
This is my classroom, primary school. It really brings back old memories. This is where we used to go. It was grass thatched at this time, but the building is more or less the same as it was many, many years ago. It's a good feeling to be here again.
Oh, yeah.
That's right. Even the door. So when I walked into that little classroom and realized that it really had retained the same shape that it had when I was there doing what we then called Standard 4, which is grade 6 now, I felt quite emotional about it. And, this is where it all started.
Our concern is post-secondary.
Both Lydia Makubu and Tom Odiambo share a vision. The vision that education, especially in science and technology, is key to the development of Africa.
Yeah, so we are really talking about catering for something in the region of 130,000 in post-secondary school education system. So really we are talking about such a large group that I would suggest that we concentrate on the normal route first and deal with it until we enter the level of the technologies.
We have already put in place some of these programs. Artisan, craft, and technician.
Kenya has decided that it has to be very technology-oriented, to be probably the first of the African tigers, if we might put it that way. And therefore, a more coherent structure of higher education is extremely important, and to bring in everybody, including the women.
The Ngurman escarpment stretches as far as the eye can see. It's part of Africa's Great Rift Valley system. At its base live the Maasai. Just 100 miles from Nairobi, they fiercely maintain their traditional way of life. For centuries, they have shared the bush with wildlife, but the thickets of Ngurman are also home to one of Africa's most dangerous creatures, a fly called tsetse. Its name comes from the distinct sound it makes. The tsetse is a biting fly, and often when it bites, it kills. Many tsetse flies carry microscopic parasites called trypanosomes in their mouths. They pick them up when they feed on wild animals. Some trypanosomes cause sleeping sickness in people, a disease which in the past has killed thousands. But much more importantly in Africa today, trypanosomes devastate livestock, which have no natural immunity to the parasites. The tsetse fly has made millions of hectares of fertile African rangeland virtually useless for agriculture. The impact on the food potential of the continent is profound, the effect on the people of Africa incalculable. The Maasai people who live here at the foot of the escarpment know about the tsetse all too well. Life here is hard enough. Except for a brief rainy season, it's dry and raising livestock is difficult. Having their cattle die from Nagana, the tsetse disease only adds to the hardship. And the Western way of fighting pests with chemical sprays has proven expensive, polluting, and not very effective.
When a major outbreak took place in 1899 in Uganda, another place, and thousands of people died, the British government just poured in people and resources to kill off this plague. And they never stopped. All through the beginning of the century, the 1920s, 1930s, 40s, even during the war, they simply had some of their best people working in this thing.
In Nairobi, Odhiambo's scientists decided to tackle the tsetse fly and its deadly bite. And they decided to do it by learning as much as they could about this most unusual fly.
Tsetse only produces young in a uterus. A uterus which is just as complex as a mammalian uterus. The insect produces probably up to 10 young in her lifetime. So we're not talking about a vast reproduction like other flies, which do it by the thousand. Here the most probably, maybe 3 or 4. But if it's a very good mother, maybe 10, 12. That's it. And yet, it is a problem. We're not talking about many flies. When we say a place is infested, actually we're talking about a few dozen insects. They're not many. So the mystery is, how can they do so much damage when they're so few?
In the 1980s, the Nairobi lab designed a large, brightly colored trap that tests showed would look like an animal to flies, including the tsetse. The idea was to collect samples for lab work and to monitor parasite levels in the flies. The design was simple enough. Once a fly entered the dark trap entrance, it was attracted to the sunlight at the top. The hot sun on the plastic bag soon dehydrated and killed the flies. But the biggest problem was to find a way to make sure that tsetse flies would be attracted to the traps from far away, long before they could see them.
We know the factors responsible for attraction, and it's the attraction towards a host that we are using to lure the insects and so trap them. So it is not that something that was done out of the blue. It is based on some real science.
All the scientists had to do was figure out how a few flies spread over many hectares of bush could always find a cow. The answer surprised everyone. It was the smell of cow or buffalo urine.
One of our young scientists, Mary Owaga, debated with herself, why is it that tsetse seem to spend a lot of time in areas where buffalo are found? because she's a good ecologist, that gradually led her to think there must be something in buffalo which attracts tsetse. And that's how she reached the fact that it's a urine. And then from then on, her work with the behavior scientists and the chemists then began to isolate a whole series of unexpected chemicals, which we are not planned for.
Individual flies, and as Dr. Otieno showed you, this is from the different areas.
Mm-hmm.
So
we're using two study areas.
Yeah.
This is a non-suppression area. Beyond here, we are not doing any suppression at all.
Okay.
So we're using that as a control.
Isipe scientists field tested the trap design with the exotic bait cow urine in the Nguruman area. They hired the Maasai to maintain the experimental traps. When it became obvious that the traps could actually clear an area of tsetse flies, they encouraged them to install more traps on their own lands. But there were problems. Over the years, mistrust grew between the Maasai and the outsiders from Nairobi. The insect lab scientists hadn't worked enough with the community to secure its support. To be sure, the Maasai would allow experiments to continue on their lands or even use the traps themselves. Just before Christmas of 1993, the local Maasai chiefs met Odhiambo, the Isipe chief, face to face to air their concerns about the trap program.
Sisi tunafanya utafiti.
By the end of the day, Odhiambo's reassurances had succeeded, and the Maasai of Nguruman were fully back in the project. But the experience reinforced one of the most important principles of scientific work in Africa. Research isn't much use if the people it's supposed to help don't feel they have a stake in its development and will apply its results to get the benefits. But the Maasai were persuaded, and now their children even collect cow urine to bait the traps as part of their early morning chores. Odhiambo's lab has applied that lesson and the other things they learned from the Nguruman experiments to one of the worst tsetse-infected areas of Africa, the Lambwe Valley. It's on the equator next to Lake Victoria. Here, the tsetse flies still transmit human sleeping sickness. For years, the valley was bombarded with aerial sprays. It controlled the flies, but only until the expensive and hazardous spraying stopped. The flies always came back, usually in greater numbers. And every time the flies returned, people were forced to move away to safer areas. As with Nguruman, scientists from the insect lab set up field stations to monitor the flies carefully. At this one, they isolate the blood in tsetses to find out what kind of animals the flies have been feeding on.
The government has tried to control this tsetse using various methods. And during the period they are controlling it, you find the population goes down. And then after a while, they leave the practice, you find that the tsetse population again comes up.
Jacob Nyangor farms in the Lambwe Valley. He and the other local farmers noticed a change in the health of their animals as soon as Isipe started testing the new trap design in the region.
One of those farmers told us that when they saw the trap for the first time, they were skeptical. And they said, how can this piece of cloth succeed where all these aeroplanes and other methods failed? Then until they saw the catch, and in their words that they filled 2-kilogram tins of tsetse flies and then fed them to their chickens, then they were convinced.
From the time now Isipe came around to control it, now we have seen a lot of reduction. So we are impressed. When they were using this trap here, the super trap, Now the population has gone down.
But tsetse scientists didn't want a repeat of what had happened with the Maasai. They wanted to be sure not only that the traps worked, but that the community would maintain them. And that meant combining the laboratory work and knowledge of tsetse flies with knowledge of the customs and practices of the local people. It meant cooperation and local participation.
And then this is not conventional again, because in the past we have been used to telling them what to do. But what we are trying to do is also give them some scientific information about the vector, the tsetse fly.
An Monica Nyango Junge, adi puonjou kuom gimochungu kani. Gini iluonge ni isipe super trap.
Because the history of this place, people were coming in, an epidemic, they move out. They come in, they move out. So now they are confident they can live here.
We think
we can trap tsetse sufficiently, sustainably, using community labor and community approaches indefinitely, and keep sleeping sickness out of the communities, almost sustainably. We think a sterling example what can be done through research for the rural.
In fact, in the test areas in the Lambwe Valley, the special traps now remove 98% of the tsetse flies, and all with an inexpensive technology that doesn't damage the environment.
We've just had our graduation and the conferment of degrees, and the chancellor of the university who comes to give the degrees is His Majesty the King. And so when the king is coming, all sorts of people are involved in making the preparations. And so we hold a series of parties for all of these groups so that I can go and thank them for the good job done in preparation for graduation.
Traditionally in Siswati, when there has been a big function, the family then gets together later and eats the remains, the head of the cow, the hoofs, and all of the things that, are remaining. But traditionally, women are not supposed to eat the head. But we decided in the university we would break this tradition and eat the head.
Our societies, let's say in Africa and in Swaziland, are in a state of transition where the modern is encroaching into the traditional. And sometimes there is conflict, sometimes the merger is quite harmonious. If you look at African society and the history of our societies, you will find that a great deal of scientific activity was taking place, even though it wasn't called science. That is why it is very important for African scientists not to limit their activities to just science if they want society to get involved, but to go deeper into what our societies are doing in areas such as agriculture, in the areas such as health, to try and translate that which is traditional into modern scientific language, because there is a great deal of science that has always been with Africa, but it wasn't written, nor was it interpreted in the way that the North has interpreted science.
Lydia Makubu has chosen to marry the traditional beliefs and practices of the culture of Swaziland with her own research work. Traditional healers still use herbs and plant recipes to treat illness, remedies that have been used through many generations. Makubu often travels into the remote mountains to collect specimens from healers, the people the developed world often calls witch doctors.
Yes, they were called witch doctors because I think in the early colonial days, much of that which is typically African was considered superstition and perhaps heathen. But I think lately we have been looking at our traditional healing system, and we found that there is a great deal of it that might be extremely useful in present-day medicine.
Even today, in the open-air markets of African cities, the traditional pharmacy with its roots and extracts does a roaring trade, while nearby shopping malls have modern pharmacies with vitamin pills and aspirin.
As we know in the history of chemistry, a great deal of the modern medicines, morphine, digitalis, came from plants. And traditional healers have been using plants since time immemorial. And therefore, traditional healing has a great deal that is scientific.
Many of Africa's traditional healers are women. Jabu Malela is one of Swaziland's most respected healers. She takes novices through a rigorous 2-year training program.
The bones that were thrown on the mat, that is a diagnostic tool. The healer reads the bones to indicate what the sickness is.
Kuyadependa lokuthi lo muntu mhlambe ufuna lokuva bona ukuthi utawubona yini lo muntu ukuthi ngisuka lelele nje kubhlungu sinye vele limvamisa yabo bafuna lokuthi ubhule atobona lokuthi uyabona yini ukuthi uphethwe ngesinye nje uqhamuka nje ugula sinye kuphela ufuna lokubhula eve ngawo lokuthi utawubona into ukuthi ugula sinye.
have ceremonial rites in Swaziland, there is something unifying about it, and there is a basis for whatever we do. It may not seem appropriate looked at from another cultural point of view, but you really have to understand the people, their history, and their whole approach to life to really be able to put the significance of those ceremonial rites into context.
Conflict at all, because I look upon it as a piece of research that I have to do. I'd like to believe that the treatment with the plants does work, because after all, that is just a pure chemical reaction, so I believe that it does work. It is hard to say whether the other part works or not. But of course, psychologically, it's very good for the patient.
While traditional healing is a vocation for some young Swazi women, Lydia Makubu has worked hard to bring many more into contemporary science as well. At St. Michael's School in Manzini, Swaziland, her commitment is rewarded as a whole class of high school women write their pre-university chemistry exams.
I believe that women have a certain way of looking at things, certain perceptions that they would bring into the whole of the scientific endeavor. In agriculture, women traditionally have been food producers. They have been involved in the tillage of the land. They are involved in the management of the environment in various ways, in procuring energy for the family. Their traditional activities are scientific activities. So I believe that if we were to modernize these activities by educating women, bringing them into science, I am quite sure that the agricultural agenda, the agenda on the environment, would have that perspective that only women can bring, the perspective that is sensitive to the family, that is sensitive to children, that is sensitive to the human being.
There is no doubt that Africa today is beset with problems that few could have imagined. Millions fleeing from famine and civil wars crowd refugee camps. The developed world has been moved to compassion, but the view of Africa that prevails today is one of a land with little hope. It's a long way from the optimism with which the world greeted the independence of Africa's countries in the 1950s and 60s. It was in that hopeful time that Tom Odhiambo had his idea to create a tropical insect lab in the tropics.
The original Isipe facility was built from an original carport without walls. We got a little fund to put up these walls and then have just one office which included everybody, the administrative staff, the financial staff, and myself. We were just only four. But we stayed here for the planning sessions, which began in early 1969 and went on until the beginning of 1970.
Tom Odhiambo started Isipe from this office in a converted carport on the campus of the University of Nairobi. Just getting walls added to the carport was an accomplishment. In 1967, Odhiambo wrote an article about how centers of excellence in the tropics could could foster both the training of scientists and the pursuit of research relevant to the Third World.
The lens fused together.
He needed allies in the First World to make his idea work. He found one such person in Carl Djerassi, the inventor of the birth control pill, and a scientist who had done much to build expertise in steroid chemistry in Mexico.
Ovulation predictor that I talked about.
I wrote it for Science, and it was Carl Djerassi who saw it. And he said, but look here, I've been advocating building up collaboratively of a science center in Mexico. And now I'm working on one for Brazil. Here's a paper that I wrote.
Talking about the question of creating centers of excellence of research in lesser developed countries, in countries that don't seem to have the infrastructure for that, who have practically no tertiary education, whose main objectives are primary education, perhaps secondary, and making the point that if these countries ever want to reach the level of a more industrialized country, they'll have to do something about creating, at the very least, using and perhaps even creating indigenous technology, and of course that in turn means science.
I actually gave an example of an institute in entomology, how that would be very useful in terms of advancing the entomological sciences, but at the same time solving a tropical problem, and devise a model for doing it.
So lo and behold, that was published, that paper, and then one day I got a letter, not so long later, from Tamo Diambo, and he said,
let's try it out on this entomological problem. That's how it started.
So I then got in touch with people at the National Academy of Sciences and the American Academy of Arts and Science.
Convincing donors that this radical idea was worthwhile still took some doing, as Ruben Olembo, one of Odiambo's colleagues at the time, recalls.
It was not only a question of funding, I should say, it was the whole question of the concept, because, you know, for years, even up to now, the assumption has been that technical assistance is a directional flow from north to south. And to say that the South could have its own ideas that could contribute to this paradigm of development was unheard of. So it was an uphill fight, not only just in terms of who will fund it, but whether the idea will fly at all.
But it did fly, and the achievement is even more remarkable because it couldn't have happened without a corps of African scientists to get it started. But during the colonial period, being an African and becoming a scientist at the same time was nearly impossible. Missionary schools rarely taught science.
In a sense, you're given the impression that the African coming to school had nothing to offer. It was a fresh vessel in which new knowledge would be poured. And the missionaries certainly acted that way. There was no ethical framework, no moral fiber, no knowledge of anything except, as you said very clearly, magical incantations. But that's just not true.
You know, the early prejudices of that era were to ascribe science to other cultures other than Africa.
Odiambo experienced it firsthand. After getting his first science degree, he got a job at a Kenyan research institute, but the British manager told him he could not become a scientist.
He told me that it has never been possible for an African to be a scientist, and he does not see why I should be a scientist. This was supposed to be foreign to your whole being as a person.
Yet archaeologists and historians now know that in Africa's past, exactly the opposite was true.
Africa would have been totally different if there had been no technological development. And I would say that the most important of these, undoubtedly, is the development of iron technology. Most people perhaps don't realize that Africans are rather unique in their technological history. They moved directly from what archaeologists would call the Stone Age to the Iron Age. And that doesn't happen in any other culture or civilization. And it was a phenomena whose results were absolutely astonishing. I mean, it allowed them literally to colonize the whole continent after about 700 BC.
And one can say that the real divide between the more intellectual environment of Africa in the past and now is the 500 years of slave trading, followed by colonial occupation.
But old attitudes die hard. Today, there are still conflicts between the scientists in Africa who are doing the actual work and the rich countries that pay the bills. Ken Pruitt, now with the Rockefeller Foundation, sat on the ISIPI Board of Governors for 6 years.
We had enormous problems with Tom. He kept funding program out of capital. We get a capital grant to build a building, we suddenly turn around and Tom's funding program. Well, donors promised to fund the program and then they didn't make their payments. What's he supposed to do, fire the scientist?
It is a constant warfare because obviously from the donor community, they would feel they have to have a say on the agenda. And we agree with them, they should have a say, but not the preponderant say. They must have a say. The African countries must have a say. The clients that we serve, the rural community must have a say.
Lydia Makubu knows how hard it is for Africans to get funds for research. She's investigating a chemical called endod found in these Ethiopian soapberry plants and the effects it has on snails. The snails may look harmless, but they hide a deadly menace.
In its breeding process in the water, it sheds little worms that are found in the water, and if a human being or whatever animal is susceptible to this, goes into the water, the parasite pierces the skin and then goes into the human system.
That parasite causes a disease called schistosomiasis. It infects more than 200 million people in tropical countries. Children often pick up the parasite. They don't have to drink the water. It's just enough to get your hands wet.
So really, we are looking at a disease that has a cycle. The human being is merely one of the stops of the parasites, and then back into the water through urination and other forms of human processes.
We estimate very many million deaths due to schistosomiasis in the world. It is a major cause of certain forms of cancer in the developing world.
Don de Savigny is a scientist with Canada's International Development Research Centre, one of the few first world organizations that does fund research projects in developing countries.
We know in school children it has effects on education, on cognitive ability. In Africa, most people are at least attempting to acquire primary school education, and children in such situations find it very difficult to perform optimally if they have chronic diseases such as schistosomiasis.
But nearly 30 years ago, an Ethiopian scientist noticed that downstream from places where women washed clothes using the berries of the soapberry plant, there were no snails. Some natural chemical in the plant was killing them. If the connection between people and snails could be broken, perhaps schistosomiasis could be prevented all over the world. For more than 20 years, the developed world failed to understand the significance of the Ethiopian discovery. Only recently has funding come to Africa so that proper tests can be done. Major trials are now taking place in Zimbabwe. There are hopes that the tests may also help solve North America's zebra mussel problem. In Swaziland, Lydia Makubu keeps a small program of her own going.
This is our snailing laboratory. So what we've done over the years has been to continually breed the snails. And then at the corner here, this laboratory tests endod for its potency against each species of snail. The aim really has been to find the minimum dosage or minimum concentration of endod that would kill the snail without killing the other water life. I look upon it as the kind of research that
has a potential for making a significant impact on society, on development.
On the shore of Lake Victoria, Charles Omondi Odiemo continues a centuries-old tradition of traveling minstrels who sing the history of the region of Odiambo's homeland. This song says, the people around Lake Victoria look on Odiambo with great pride.
Okay. Hello. Yeah. Hello. Oh, no, Ambassador.
Professor Odiambo hails from this part of the country. His work is well known throughout the world. And that's all I can say. For me, it's a privilege to be able to introduce him here, accompanied by his wife, Jerosa. Thank you very much indeed, Professor Odiambo.
The message he brings to Kisumu, Kenya's third largest city, is firm. He tells the hometown crowd they must stop being beggars.
If Kisumu is going to develop as a regional metropolis, technology must now come in a big way. So our new industries must be technology dominated. Our agro-industrial activity must be technology dominated. Our farming must be better than it is, built certainly on the foundation of traditional knowledge, but certainly they must begin to introduce new technologies. We can surely abolish famine and outlaw malnutrition. We have all the knowledge. We can abolish it. We don't have to have it. So that's one goal we can reach within 1 decade. We do not need food aid in this region. And we should not degrade ourselves by depending on food aid, because we don't need food aid.
Tom Odiambo's call for self-reliance sits well with the people of Kisumu. He has led by example. In the Swazi cities of Babane and Manzini, Lydia Makubu is also a celebrity. She holds more power and influence than most of the men in her country.
Well, people just greet me. A lot of people I do not know actually know me. But I was born here, so I try to behave as the daughter of the soil as much as possible. I'm just an ordinary Swazi woman after all.
Ordinary maybe, but a woman who's made a difference. Witness Kisi Mdluli. He's just completed his doctoral work in biochemistry in Canada. When he was Makubu's student in Swaziland, she convinced him to apply for a scholarship from the Canadian International Development Agency. 5 years later, he's ready to go home.
There has been times when, during the course of the 5 years that I've been here, that I sit back and go, will I ever be able to do this? Does this even make sense? And after I do this and I get my PhD, what exactly am I looking to do with it? Am I even making sense doing what I'm doing, or am I wasting my life? And then I look ahead and say, well, it's been done before.
And finally, there has been recognition for the work done before by Tom Odiambo and Lydia Makubu from universities in the developed world.
Thomas Odiambo, in gratitude for your scientific leadership, your tireless service, and your inspiring example as a visionary and humane educator, the Johns Hopkins University confers upon you the degree of Doctor of Humane Letters, honoris causa.
and who has become a role model for women in education and science everywhere, but especially in nations learning to play new roles on the world stage.
In the name of this university and by the authority of Royal Charter, I admit you to this degree with all its rights and privileges.
ISIPE, if you measure it against sort of international world standards, it's not as strong as we would wish it. If you measure it against the conditions under which it tried to come into being and be a serious institute, it's a remarkable accomplishment. It still remains many people's idea of what the goal for scientific institutions in Africa should be.
Well, of course it was successful because it became Africanized. If it had not become that, and it would, even if it had had much greater scientific results and so on, I would not have considered it a success.
That part of the objective still remains the central theme in ISIPE's work. I would not say that it's been satisfied because it's a long struggle.
It's a science for Africa. It's a science which is, after all, ecologically sound, ahead of its time, way ahead of its time. It's a science that's got to reach into the farmer's fields to see that the stuff is really working, can be adopted.
This song, sung in the Shona language of Zimbabwe, calls on the people to bear witness to accomplishment. As Lydia Makubu boards her plane, she starts her long journey to the north to promote and raise money for science and education in Africa. And as Thomas Odhiambo arrives to deliver his last speech to the staff of ISIPE, they too think about Africa's accomplishments.
We have seen an idea grow from very small beginnings to now what we had hoped it will be, and that is a global research institute.
We must take the leadership. And the North, we will still depend on the knowledge and the financial assistance and assistance of other kinds. But I think we have realized that the leadership must come from Africa.
The donors are not interested in begging. What they're interested in, if Africa really wants to go forward, is in partnership. We were clear that this institute is very much geared towards Africa. It's an African institute. There are no doubts about that. The view was absolutely African. ISIPE has always been Africa-based, reaching the highest level of excellence, wanting to help the people of Africa. I would like to sleep well as I've slept all these years, very well, innocently. That indeed the wisdom that was implanted in this institution prevails and continues. And that you, as pioneers, continue to perform. Be firm, and let's grow, because if you grow, Africa also is likely to begin to grow.
One of the biggest things that we can teach the North is resilience. If you think of the problems that Africa has gone through and is still going through, and yet we are still breathing, I think we can teach people a lot about survival.
Yeah.